Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to take a look at solving literal equations, which is a topic that sometimes shows up on the Armed Services Vocational Aptitude Battery. That is the ASVAB. More specifically, we're going to start this video by taking a brief look at the definition of a literal equation. We'll work on one example problem together. But after that, there are going to be 13 practice problems for you to work on. Again, if you're new to my channel, I want to stress this again. I always recommend that you attempt to work out all the practice problems on your own. That is to say, when I read a question, you should pause the video, attempt to work it out on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. All right, so as mentioned, we're going to start today's video by reviewing the definition of literal equations. And as we can see, literal equations are equations with multiple variables, and more often than not, you are asked to solve for just one of the variables. Usually, literal equations represent formulas used in the sciences, such as physics or geometry. All right, to solve literal equations, it's the same process you use to isolate variable in an algebraic expression. That is to say, we're going to make use of addition, subtraction, multiplication, dividing, and factoring to isolate our variables. This review is going to be very brief because in order to get the most out of this video, you really just have to practice. So that said, let's take a look at our first example. It says solve d over t equals r for t. So I'm going to start by copying this one off to the side. We're given the equation d over t equals r, and we want to solve this literal equation for t. And as we can see, t is down here. The very first thing I'm going to do is multiply both sides by t to get it out of the denominator here. This will cross out here, leaving you with just d on this side. And now we can see d equals r times t. That's the distance formula. You probably recognize it. And now just to solve for t by itself, we're going to divide both sides by r. This crosses out here, leaving you with t on this side. And we can see t equals d over r. In math, it's customary to write the variable for which you solved on the left. So we're going to express this as t equals d over r. All right, and so we've done what this question's asked us to do. Notably, we've solved for t. So again, all we did was use multiplication here and then some division here. So that said, let's go ahead and get to the practice problems. Again, I want to stress this. You should be working on all the following problems on your own. In total, there are 13 of them. So I recommend you pause the video after I read a question, attempt to work it out on your own, and then resume playing the video to either check your solution or in the event that you get stuck. This first question says, solve d equals r times t for r. D equals r times t is the distance formula. You should know that if you've been watching my videos. But that said, I'm going to start all these problems by copying them down. Again, we have d equals r times t. And in this case, we want to solve for r. That is, we want to solve this literal equation such that we end up with r equal to something by itself. In this case, this says r times t. In order to move this t to this other side of the equal sign, we're going to do the opposite of multiplication, and the opposite of multiplication is division. So we're going to divide both sides by t. This crosses out here, leaving you with r equals d over t. And in math, it's customary to write the variable for which you solved on the left. So this becomes r equals d over t. And at this point, we've done what the problem's asked us to do. Notably, we've solved for r. All right, so that's that one. Pretty simple and straightforward to start. And let's go ahead and look at number 2 now. Number 2 says solve p equals 144 p over y for p. In this case, I want to point something out. There are two p's in this problem. There's a big P and a little p, and we're being asked to solve for the little p. Again, this is capitalized, this is not capitalized. So that said, let's copy this one down. We have P equals 144 little p over y. Let's read this fraction here to make sure we know what it says. It says 144p divided by y. Again, we're trying to solve for p, so we want to get p such that it looks like this, p equal to something. And so our first step is to make an effort to clear this y from the denominator. Again, this is divided by y, so we're going to do the opposite operation. That is to say, we're going to multiply both sides by y. This will cross out over here, leaving you with 144p equals big P times y. And now at this point, all we do is have to clear this 144. This says 144 times p, so we're going to perform the opposite of multiplication to move 144 away from little p. That is to say, we're going to divide both sides by 144. This crosses out here, leaving you with p equals, and let me go down a line so we have some room to write that. P equals big P times y over 144. Again, in math, it's customary to write the variable for which you solved on the left, so we can write this as P equals P times y over 144. And we've done what this problem's asked us to do. Notably, we've solved this expression for little p. All right, so that's that one. Number 3 says solve p equals a plus b plus c for b. All right, this one's actually pretty easy to do, but that said, let's go ahead and copy it down. We have p equals a plus b plus c, and we're trying to solve for b. Again, over here we have a plus b plus c. That is to say, this is all addition. In order to get b by itself, we have to move a and c to this other side of the equal sign. So this is a plus b. We're going to perform the opposite operation and subtract a from both sides. This will cross out here, leaving you with b plus c over here, and this says p minus a. All right, finally, let's get rid of this c, and again, we're going to perform the opposite of addition, notably subtraction, in order to move it to the other side. This crosses out, leaving you with b equals p minus a minus c. And again, in math, it's customary to write the variable for which you solved on the left. So this is b equals p minus a minus c, and we are done. That is to say, we've solved for b such that it looked like b equal to something. All right, so that's that one. Again, another simple problem there. Number 4 is a little more challenging. As you can see, it says solve a equals a plus b plus c plus d over 4 for c. So let's copy this one down. We have a equals a plus b plus c plus d over 4. And we're trying to solve for c at this point. Again, you could read fractions two ways. This says a plus b plus c plus d over 4. Or this says a plus b plus c plus d divided by 4. Again, we want to get rid of this 4 such that we can eventually solve for c. So I'm going to do the opposite of division here, and I'm going to multiply both sides by 4. This crosses out here, leaving you with just a plus b plus c plus d over here, and this is 4a over here. All right, we're solving for c now, and you can either move a, b, and d to the left all at once, or you could do it one by one. It's really up to you. I'm going to do it all at once, so I'm going to subtract a from this side, b from this side, and d from this side, and we're going to subtract that from both sides, so minus a minus b minus d. This crosses out here, here, and here, just leaving you with c over here, and this becomes 4 big A minus b minus d. And again, in math, it's customary to write the variable for which you solved on the left. So this says c equals 4 big A minus A minus B minus D. And we have solved for C at this point, so we are done. All right, so that's that one. All right, number 5 says solve m equals y2 minus y1 over x2 minus x1 for y2. If it's not obvious, this is the equation to find the slope of a line. And in this case, we want to solve for y2. In other words, we want to solve this equation such that y2 is equal to something by itself. So let's start by copying this one down. Again, we have m equals y2 minus y1 over x2 minus x1. Again, we're solving for y2, but we have this x2 minus x1 in the denominator. We want to clear it. Again, this says divided by x2 minus x1. So we're going to perform the opposite and multiply both sides by x2 minus x1 to clear it from the denominator. This says x2 minus x1. This will cross out here and here, and this just leaves you with y2 minus y1 over here. And you could leave this like this, and I'm going to do that just for the time being. Again, over here we have x2 minus x1. Again, this is all times m. And at this point, the only thing we have left to do is to get rid of this minus y1 here. Again, this is minus y1. The opposite of subtraction is addition, so we're going to add it to both sides to get rid of it. This crosses out here, leaving you with y2 over here. So this is m times x2 minus x1 plus y1. All right, so let me just stress this. At this point, we could solve this one by saying in math, it's customary to write the variable for which you solve on the left and write it like this. y2 equals m times x2 minus x1 plus y1. This is a correct solution, but there's multiple ways to express this. So let's go ahead and take a look at those in case you came up with something else. First and foremost, you can simply write this like this. y2 equals x2 minus x1 times m plus y1. That is the same thing. And what's more, you could have also taken this m and distributed it here and here, and that would look like this. y2 equals m times x2 minus m times x1 plus y1. All right, so for this one, you could have had 3 different solutions, and they're all the same. All right, so that's that one. All right, number 6 is one of the more challenging problems in this video. I'm just going to say that. And it says, solve 1 over f equals 1 over a plus 1 over b for f. All right, so take your time as you do this one. If you solve this one too quickly, chances are you're not going to get it right. So in this case, we have 1 over f equals 1 over a plus 1 over b. So what we want to do is solve this equation such that we isolate f at the end such that f is equal to something. So to start, I'm going to take this f and multiply it here, and I'm also going to multiply it over here because I want to clear that f from the denominator. Can't have 1 over f equal to something. We want just f equal to something. When I do that, this is going to cross out here, leaving me with 1 equals, again, this is 1 over a plus 1 over b times f. All right, now I'm going to take this f and distribute it here and here. So this becomes 1 equals 1 over a times f. Let me work this off to the side so you don't get confused as to how to do that. You have 1 over a times f. That is to say, we're multiplying a fraction by a whole number. In order to multiply fractions, we're going to rewrite this one as a fraction by placing it over 1, and then we multiply straight across. So this becomes 1 times f, which is just f, over 1 times a, which is a. So this becomes f over a. And it's the same thing here. Again, this is 1 over b times f. In order to multiply these two, I'm going to write f as a fraction by placing it over 1. And then when you multiply fractions, you multiply straight across. So this becomes 1 times f, which is just f, over b times 1, which is b. So this is f over b. All right, so you might be saying to yourself now, how am I going to clear these f's? They're in fractions. Well, we're actually going to add these fractions together. And when you add fractions, they have to have the same denominators. In this case, I'm going to rewrite the fraction f over a and f over b such that they have a common denominator. Well, what's a common denominator between a and b? Well, it's AB. So let's go ahead and rewrite this. This is going to become 1. Again, our common denominator is going to be AB plus AB. How can I write A to be AB? Well, I can multiply it by B, and I'm also going to have to do that to its numerator. So this becomes B times A, which is AB, over F times B, which is FB. How can I write b such that it becomes ab? I can multiply it by a. I'm also going to do that to the numerator. So this is going to become fa. Now that I've rewritten these fractions with the same denominators, I can go ahead and add them. So this becomes 1 equals fb plus fa all over ab. Now, again, our goal is to solve for f. We're almost there. We just got a few more steps to do. So what I'm going to do now is clear this ab from the denominator. And again, this is fb plus, and this should be an a right here. Sorry about that. This says fb plus fa over ab. Well, how can I clear this ab? This says fb plus fb divided by ab. So we can multiply both sides by ab. This will clear here, and this will become this. FB plus FA. 1 times anything is itself, so AB times 1 is just AB. Now, how can I clear this over here? We have F times B plus F times A. Well, I can factor out an F here, so I'm going to factor out an F. This will become B plus A equals AB. And now I can just divide both sides by b plus a. This will cross out here, leaving me with just f. And as we can see, f is ab over b plus a. And in math, it's customary to write the variable for which you solved on the left. So again, this is f equals a times b over b plus a. And just like that, we solve for f. Pretty tricky problem, but nothing too difficult. But that said, we had to use some multiplication. We had to add fractions. And then we had to use some simple factoring in order to get this one such that we had f equal to something by itself. All right, that's probably the hardest problem in this video. So if you have to watch that one again, go ahead and do so. Number 7 says r equals L plus 3 W over 2, and we're solving for W. Let's start by writing this one down. We have R equals L plus 3W over 2, and we're solving for W. This one's pretty easy. The very first thing we want to do is clear this 2 from the denominator. That is to say, we're going to perform the opposite of the operation that's occurring here. This says L plus 3W divided by 2. So we're going to multiply both sides by 2. This crosses out here, and this becomes 2r equals L plus 3w. Again, we're solving for w, so the very next thing we're going to do is move this L to the other side. Again, this is L plus. We're going to perform the opposite of addition to get rid of this L. That is, we're going to subtract it from both sides. This crosses out here, and this becomes 2r minus L equals 3w. We're almost there. We just want to solve for w, not 3w. And this says 3 times w, so we're going to perform the opposite operation, notably division, to get rid of it. This crosses out here, leaving you with w equals 2r minus L over 3. And again, in math, it's customary to write the variable for which you solved on the left. So this becomes w equals 2r minus L over 3. And that is our solution to this one. All right, let's move on to the next one. So number 8 says solve y minus y1 equals m times x minus x1 for x. So let's start by copying this one down. We have y minus y1 equals m times x minus x1. And again, we're solving for x. The very first thing I'm going to do in this problem is take this m and distribute it here as well as here. So this becomes y minus y1 equals m times x, which is mx. Let me fix that m here. My pen's starting to act up a little bit. Minus m times negative x1, so that's negative mx1, which is this. All right, we're solving for x at this point, so we want to get rid of this minus mx1 from this side. Again, we do the opposite operation to move it to the other side. This is minus, so we're going to do plus m. My pen is starting to die on me here. Plus mx1 to both sides here. This crosses out here, leaving you with just mx on this side. And as we can see, mx is y minus y1 plus m times x1. All right, now we want to get rid of this m. This says m times x. We're going to perform the opposite operation to move it. So we're going to divide both sides by m here. This will cross out here, leaving you with just x over here. And this becomes y minus y1 plus mx1 over m. And in math, it's customary to write the variable for which you solved on the left. So all told, this becomes x equals y minus y1 plus m times x1 over m. And we are done with that one. All right, let's take a look at number 9 now. Number 9 says solve c equals 5/9 times f minus 32 for f. All right, this is the formula to convert from Fahrenheit to Celsius. You don't necessarily have to memorize it for the ASVAB, but I'm just pointing out that that's what that is. Let's go ahead and copy this one down. We have c equals 5/9 times f minus 32. All right, so the very first thing I want to do is get rid of this 5/9 from this side. And in order to get rid of this fraction, I'm going to multiply it by its reciprocal. Again, a reciprocal is just a flip-flop of the fraction. So if I were to replace this, if I were to flip-flop this, this would become 9 over 5. And I'm going to do that to both sides. This crosses out here, leaving you with just f minus 32 over here. And this becomes 9 over 5 times c. All right, to solve for f, it's just a matter of getting rid of this minus 32. So we're going to do the opposite of subtraction and add it to both sides now. This crosses out here, leaving you with just f over here. And this becomes 9 over 5c plus 32. And again, in math, it's customary to write the variable for which you solved on the left. So this becomes f equals 9 over 5c plus 32. All right, so let me just point this out. In the formula that was given, this tells you how to convert from Fahrenheit to Celsius. Since we solve for F, this tells you how to convert Celsius to Fahrenheit. Okay, so I just wanted to point that out. All right, let's look at number 10 now. It says solve 1 over r equals 1 over r1 plus 1 over r2. And we're solving for r. This is very similar to a problem we've done already. And when I worked out that problem, I said it was probably one of the hardest problems in this video. Well, this is your second chance to solve one of those hard problems. So let's go ahead and tackle this one. To start, let's go ahead and copy it down. We have 1 over r equals 1 over r1 plus 1 over r2. We're solving for r, which is right here. So previously, when we had a value for which we were trying to solve in the denominator, we brought it up to the numerator. And in that case, we multiplied both sides by r. So that's what we're going to do here. This will cross out here, leaving you with just 1 on this side. And as you can see, we have r times 1 over r plus 1 over 2. So we're going to take this r and distribute it here as well as here. Now this isn't straightforward to do if you're not very good with fractions. So let me do this off to the side. This first one says 1 over r1 times r. Again, I can write r as a fraction by placing it over 1, which will enable me to multiply these straight across. This becomes 1 times r, which is just r, over r1 times 1, which is r1. So r times 1 over r1 is r over r1. This is going to be the same thing. We have 1 over r2 times r. Let's write r over 1 and then multiply straight across as we normally would. 1 times r is r. r2 times 1 is r2. So this is plus r over r2. All right, so now we have to add fractions, as you can see. But that said, our denominators are different. This is r1, this is r2. In order to add fractions, you have to have the same denominators. So what I'm going to do right now is rewrite these two fractions such that they have a common denominator. And that common denominator is going to be r1 times r2. And the question is, how can I write r1 such that it has a denominator of r1 times r2? Well, I'm just going to multiply it by r2. And I'm also going to do that to the numerator here. So this becomes r1 times r2, which we have. But in the numerator, it becomes r times r2. And the question here becomes, how can I write r2 to be r1 times r2? Well, I'm just going to multiply it by r1. I'm also going to do that to its numerator. Again, this becomes r1 times r2, which is right here. But in the numerator, we now have r times r1. All right, let me scroll a little better. All right, now that we have fractions with the same denominators, we can write them as one big fraction. So this becomes 1 equals r, and I'm going to drop the multiplication symbol since that's implied, r2 plus r1 over r1 r2. All right, so now we want to clear r1 r2 from our denominator, so we're going to multiply both sides by it. Again, this says divide it by R1, R2. To get rid of it, you perform the opposite, which is multiplication in this case. So we're going to do R1, R2, and we're going to do that over here as well. So this becomes times R1, R2. This crosses out here, leaving you with R times R2 plus R times R1. And 1 times R1, R2 is just R1, R2. All right, so at this point, you're probably saying, well, how am I going to solve for just R now? And right here, we can just factor out R right here, and this will leave us with R2 plus R1 equals R1 times R2. And let me go ahead and finish this problem over here. Again, we have, I'm just going to copy this over here. We have R1 times R2 equals R times R2 plus R1. Again, we want to solve for R, so we want to get R by itself. So I'm going to divide both sides by this R2 plus R1. This crosses out here, leaving you with just, and let me move over a little bit, leaving you with just R over here. And this, as we can see, is R1, R2 over R2. Let me fix that real quick. R2 plus R1. All right, so in math, it's customary to write the variable for which you solved on the left. So this is going to be R equals R1 times R2 over R2 plus R1. And now we have solved for R. This is the second example of a difficult problem. So I hope by seeing two examples, you can see how they're solved. As always, fractions usually complicate things. So again, if you need to rewatch these two problems, I would recommend you do so. But that said, let's go ahead and move on to number 11 here. All right, number 11 says solve S equals R minus little r times big R for R. So let's start by copying this one down. We have S equals big R minus little r times big R, and we want to solve for big R. Well, how can we do that? From this right-hand side, it may not be obvious, but we can factor out a big R. So this will become S equals, let's factor out a big R. This will become 1 minus little r. And now, to solve for just big R, we're going to divide both sides by 1 minus little r. This crosses out here, leaving you with just big R on this side, and this becomes S over 1 minus R. Again, in math, it's customary to write the variable for which you solved on the left, so this is big R equals S over 1 minus little r. All right, so that's that one. Number 12 says solve V equals 1/3 pi h squared times 3 r minus h in parentheses for little r. All right, so let's go ahead and start by copying this one down. We have V equals 1/3 pi h squared 3 little r minus h. We want to solve for little r, which is right here in our equation. All right, the very first thing I'm going to do is get rid of this 1/3. Again, in order to get rid of fractions, you multiply them by their reciprocals, which means you just flip-flop them. So to get rid of 1/3, we're going to multiply it by 3 over 1, which is just 3. And we're going to do that to both sides. This crosses out here, leaving you with pi h squared 3r minus h over there. And this is 3v over here. All right, so let's go ahead and take this pi h squared and distribute it here and here now, this becomes 3v equals 3r pi h squared minus pi h. H squared times h is h to the third. All right. And now what can we do to solve for r in this case? Well, the very first thing we can do is add pi h cubed here and here. This will cross out here, leaving you with 3v plus pi h cubed equals 3r pi h squared. All right, so I'm solving for r now, which means I want to move all this other junk over here. And so I'm going to divide this side by everything except r, notably 3 pi h squared. Again, this will cross out the 3 here, the pi here, and the h squared here. And again, we're going to be doing that to both sides. So this is going to be divided by 3 pi h squared. All right, and now we're just left with r equals 3v plus pi h cubed over 3 pi h squared. Again, in math, it's customary to write the variable for which you solved on the right. So this is r equals 3v plus pi h cubed over 3 pi h squared. And just like that, we solve for r. All right, so that's that one. And the final problem in this video says solve for pi when given a equals 2 pi r squared plus 2 pi r h. All right, so let's go ahead and work on doing that. To start this one, I'm going to copy it down. We have area equals 2 pi r squared plus 2 pi r h. And you might be saying to yourself, what's the approach to this one? How can I solve for pi? Well, I can actually factor out a pi from this left-hand side or this right-hand side of our literal expression here, or equation. And when I factor out pi, I'm left with 2r squared plus 2rh. And again, we're solving for just pi by itself. This says pi times 2 pi r squared plus 2 pi rh. So we're going to divide both sides by 2r squared plus 2rh. Again, we're going to divide both sides, so 2r squared plus 2rh. This crosses out here, leaving you with just pi on this side. And as we can see, pi is a over 2r squared plus 2rh. And in math, it's customary to write the variable for which you solved on the left. So this is pi equals area over, or a over 2r squared plus 2rh. All right, so that's that one, and that is it for this video. I hope you found it helpful. Again, solving literal equations is a topic that sometimes shows up on the math sections of the ASVAB, so make sure you understand how to do it. Again, you're just using some addition, subtraction, multiplication, and division, and in some cases factoring to solve for a given variable. As you saw, for the most part, it's pretty easy, but when you have to deal with fractions, things always get messy. So as always, you're more than welcome to leave feedback in the comments section below. On that note, I'm going to go ahead and cut you loose.